All right, on 422, 41, we're doing exactly like we did with the pennies in class, guys. We're going to have X and Y, except up here, our pennies and our tower, our table is kind of backwards. Down here, the table's correct. The X is on the left, the Y is on the right. We like it. It's in the form that we kind of consider to be nice. So my X's need to get up to a maximum value of 9. My Y's need to get to a maximum value of 28. But what's nicer than those numbers would be like 10, if I want to overshoot, or 30. Right? So if I say that my Y's need to go to 30, and I count my boxes here, and I actually have 16 boxes, a scale of 1 to 1 it'll only get me up to 16, right? If I go 1 to 1. So I need to choose a bigger scale, right? Like 2 or 3 or 4 or 5. And when I think about going 2 for every box, 2, 4, 6, 8, I can get all the way up to 32, which is further than I need to go. So we're going to choose a scale of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Probably the guy that gives up his lunch, so we can do math. So then my X's, opposite problem. If I count by ones, I only use this much of the graph. And that's silly. So we want to spread out our scale. And instead of like we did on the Y, we're going to make a box worth more than 1. We make a box worth less than 1. So essentially, think about what if I go 2 boxes is 1. And I'm going to use a pencil really quickly to think this out. 1, 2, 3, 4, 5, 6, 7. And remember, these numbers are going on the lines. Some of us are goofing that up, that we're putting the numbers in between the lines. They go on the line because that line represents that number. So we can get up to 9. We like that. So I'm going to choose a scale that is every 2 boxes equals 1 on my X. Any questions at this point for scaling? Okay. Oh, we're going to get there. So then, just give me like 60 seconds and we'll be ready to move on. We plot all of these. And this, we have to remember, is X, comma, Y. Our X-axis being the left and right. Our Y-axis being the up or down. So, like to graph 6, 18.9, I go to an X of 6. And then I got to go up to 18.9. So there's 20. This would be 18. 18.9 would be like right between them. So it'd be like there. I'm going to grab a different color pen so we can see this a bit easier maybe. Use orange. So like 2, 6.3. The X is 2, so I go to an X of 2. The Y is 6.3, so I go up 2, 4, 6, and a little bit more. 6.3. 9, 28.35. I go out to 9. I go up. That would be 30, so I come back a little bit. Remember, halfway up these boxes would be the next number. So if this line was 28, in between the box would be 29. So that point's probably a tad bit high. 1, 3.15. 1, 3.15. Once we graph all these points, the way we check, is it proportional? Can I start at 0, 0 and draw a straight line through them? Yes, we can. Questions on 41 still? Any of my Math 7 peeps? Questions on 41? Landon, are you working on something or are you just hanging out because I had told you to come here? Okay, just checking. All right, on the back. Here. Yeah, that was the other one I was about to hit specifically. The top and the bottom tightrope are the same lengths. If you guys want to kick that door shut or whatever. And Max, yeah, it's because Perry's going back to class right now. So that's the first thing we need to realize, is this top tightrope is 21 and R. Right? It's the same as the bottom tightrope. But when I compare them with each other, I see that they actually have a piece that is identical on the top and the bottom. So if you're asking about this one, what'd you get? R is?
They're saying not C, but yeah, R is 6.
R should be 6. Max, what's up?
I'm confused on number 5 on the chapter 4 math 30.
So hang on just a minute. After I do this question, you can sit over here and chat with me. So if you want to just come on over, you can. Do you have more food to eat?
I mean, it's in Mr. S's thing.
Well, go take a couple more bites and then come back to work with me because I need like a minute to talk about this question.
What's this here?
R is on the top tightrope and the bottom tightrope. So I can take R off of both tightropes. That would be like subtracting the same thing from both sides, my Math 8 people, right? That's algebra. So now my tightropes are only what's on the right of my orange pen. Or that's at least all that I care about. I could also take 3 off of both tightropes. What happens if I take 3 off the bottom tightrope here? It turns into 18, so I can draw a line right here and say what's left over is 18 from here to here. And that 18 is 3R, so what does each R need to be? 6. Now, what's misleading? This looks like R is the same size as 3, but it's not. You cannot trust what you see. You got to do the math. Right? We can't trust just what we see. All right, I'm going to go tell Max that I can help them for a second. We got like 7 minutes left, so you still got time to get stuff done, guys. If you're still working on 422 and you need this part of it, we went over this in class. You are not doing the math. You are talking about what allowed them to get from one step to the next step. We don't really know the distributive property yet. That is coming. It is literally like our next section that we're learning about. So I went ahead and gave that to us in class. Turn my fan to try to dry this off too. No, yeah, your whole binder's over here.